Welcome to question 4, which is in part A about differentiating, and in part B it's about integrating. So let's get started with A. So find the gradient of the curve at the point P. So we have our point P up here, and we want to know what the gradient is of this curve that we have. So let's differentiate our equation. Here we get given our equation. So y is equal to 14 minus x to the 4. So let's differentiate that. So the y is going to become dy over dx, and we're going to get 14. That's going to become nothing, so we can just cross that out there. We're going to get this minus 1x to the power of 1. So we're going to get a minus 1 here because we take 1 from the power, and minus 1 remains. And then we get minus 1 times by 4, so we're going to get minus 4x, and then drop this power by 1, take away 1 from it, and we get a cubed there. So find the gradient at point P. So we have our function, our equation rather, for finding the gradient. So let's put the numbers in. So at P, well, what is x? Well, x is 1 there, they're giving us that. X is 1, so we can say at P dy over dx is going to be equal to minus 1 minus 4 times 1 cubed. So I may have been too simple there, but I think it's better to be too simple in some ways. So what is that going to be equal to? Well, 1 cubed is going to be 1, times by minus 4 is going to be minus 4. So our gradient at the point P is going to be minus 5. That's all there is to it, really. Just differentiate it and then put your x coordinate in for whatever you like. So let's move on to the next one. I'm talking too much. Let's move on to part 2, part II. So hence find an equation for the tangent to the curve at the point P, giving your answer in this form. So they're giving us a form that they want. We'll deal with that at the end. So find an equation of a tangent to the curve. So a tangent is going to be some kind of line that comes across this at point P. You know, a straight line that does that, not the one that I've drawn. So let's mark this out here. This is II, this is part I. So what we want to do then is use our equation y minus y1 equals mx minus x1, where x1 and y1 is the point that we know. So x1 is going to be 1 and y1 is going to be 12, the x and y coordinates of the point we know. And m is unintuitively our gradient. I don't know why it's m, but it is. So we have y minus y1, which is 12. 12 equals minus 5 amounts of x minus 1, because 1 is our x coordinate here. And then we just have to get it into this form that they want it in, so this form like that. So let's times out the brackets first. So we get y minus 12 equals minus 5x plus 5. Then what can we do? Well, we should probably add 12 to both sides, and then we should be okay. So let's do that in another colour. Let's add 12 to both sides. I'm going to go down a little bit as well, just to give myself some room. So y is going to be equal to minus 5x, and then 5 plus 12 is going to be plus 17. That is the equation of our tangent, this badly drawn purple line over here. So I don't know if you can see, I think you can see that. I think my boundary doesn't go too far. So let's do question B, which is the opposite. It's an integration question worth 5 marks, plenty of marks available for this. So what I'm going to do first is, let's not worry about this 1 and this minus 2 for now. We'll come back to that in a minute. Let's just integrate generally. So let's integrate this 14 minus x minus x to the 4 dx. And the reason why we have this dx here, it often looks kind of useless. It's like this integral here, that's like the opening brackets, and this dx is like the closing of the brackets, so you can write more things afterwards. So it doesn't really come up in A level, but maybe if you do maths at a higher level it'll come up. But anyway, let's integrate this. So we've got our integral is going to be equal to, so this is going to be equal to, so 14 x to the 1 over 1. I'm not going to write that in, but you know what I mean. So then we have a minus x, that's going to be squared over 2, because we increase the power and divide by what we have, and then minus x to the 5 over 5. I hope you followed me through that. So now I'm going to bring these two numbers back in. What can we do with those numbers? Well, what we're going to do is say this is our general integral here. So let's take number 1 as our x and put that in there, then take away what we get when we put minus 2 in there, and then we should get the area under the graph between 1 and minus 2 there. So we should get everything, so all this grey area and all this area, everything basically under the line in between these two purple lines here. And that's what we should get at the end. So let's do that. Let's put 1 into this equation. So I'm going to move down a little bit again. So we have our number 1 within our bracket. So 14 times 1 is going to be 14. And then we're going to have minus 1 squared over 2, which is going to be minus a half. Then we're going to have minus 1 to the 5 over 5. So minus 1/5. So that's what we get when we put 1 in. Then we're going to take away what we get when we put minus 2 in there. Let me use another colour actually for that. Let me use, what colour haven't I used? This lighter blue. So a lighter blue for this. So what happens when we put minus 2 in there? Well, we're going to get minus 28. Then we're going to get minus 2 squared, which is 4. So minus 4 over 2, which is going to be minus 2. I think that's right, isn't it? Yes, that is indeed right. And then we're going to get minus 2 to the power of 5, which is going to be 32, or minus 32, but we already have a minus here, so it's going to be plus 32 over 5. That's what we get there. So we need to calculate what's in here, and then take away what's in here, and that will give us the area under there, or more importantly, the answer to this question. So let's move down a little bit more. I'm going to draw a line under that, and we can go in this direction over here. So let me use red. So what is you know what, we're not going to go over there, ignore that. We're not going to do that, we're going to go down because it makes more sense. So we're going to have 14 minus a half minus 1/5. What is that going to be? Well, it's going to be 13.5, take away 0.2, so 13.5, take away 0.2, so we're going to have 13.3, if my maths is correct in my head, I think it is. Then we're going to be taking away minus 28 minus 2 is going to be minus 30, and then plus 6.4, so that is going to be minus 23.6 minus, so plus 23.6. I hope my mental maths is correct here, otherwise I shall look highly foolish. And then in green for the answer, what are we going to get? We are going to get 36.9. 36.9, that is correct, I think. So 36.9 is our answer to this question, this 5-mark question. So it wasn't, it wasn't too bad. Just split it up. So ignore the two boundaries, do it generally, and then the top one minus the bottom one. It's just practice, I think. So So let's move on to the last question, because this video is running a bit long. So hence find the area of the shaded region. So this one is quite good. They ask this question quite a lot actually. Let's go back up to our diagram. And they ask this a surprisingly high amount in the exams that come up. So the triangle that we have is this one here, this triangle. So what we've calculated just then, and we got, what did we get? 36.9, that's what we got. So 36.9 is everything. So this, under this line here, under that, between that line and the x-axis, so this blue area here and the grey area is 36.9. So what we're going to do is, if I just write it up here, so we're going to do the whole area, so that 36.9, then we're going to take away the triangle. And what that will give us is just this grey area in here. And the way you calculate the area of a triangle is just, the base times the height times half. That's how you do it in primary school, I think. So let's do that. Let's do it down below. I think we've got. Let's get the coordinates first. Do I mean the coordinates? I think I do. So -2 to 1, so that's going to be a base of 3, there, and then from 1 up to 12, so we're going to have 12 up here, so we're going to have 3 times 12 times a half. Let's do that down here because I have more space. So let's draw a line under that and say, right, so 36.9 take away 12 times 3 times a half, not 12, that's wrong, times a half, so 3 times by 6 is going to be 18, so 36.9 minus 18, let me write that, 36.9 minus 18, I'm just thinking out loud here now, that is going to be 18.9, as it happens, 18.9. That is the area of our shaded region. If I go back up here, so this purple area here, this is 18.9, and this area in here, this kind of light blue area, is going to be 18. You don't need to know that, but the answer to this question here is 18.9. That is the shaded region. So see you on the next video.